In this video, we're going to take a look at a simple demonstration of full duplex UART implementation on array boards. UART communication uses a single channel to transmit data. One end acts as a transmitter and the other end as a receiver. For full duplex implementation, two separate connections exist for simultaneous data exchange. We start as usual by creating a new array project in E2 Studio. Let's name the project UART_full. We shall select the EK RA6 M4 board and proceed next. Keeping the default configurations, we click Finish to create the files for a bare metal project. Now, because we have initialized the project files based on an EK RA6 M4 board, some of the ports are already assigned for certain standard functionalities. In the Pins tab, we are going to look into the communication ports and disable the ones which does not concern UART communication. This will also free up the pins which may be redefined as UART ports. For this demonstration, we are going to utilize channel 2 and channel 7, both of which can be set for asynchronous UART communication. Once we set the operation mode, the RX and TX pins will automatically be assigned. We shall then add the necessary stacks for this implementation. We need to add two UART stacks. For the first stack, which is conveniently named G_UART0, we shall assign channel 2. This will configure the RX and TX pins for this channel with the pin number we had set previously in the Pins tab. Likewise, we shall configure the second stack with channel 7. We will then generate the project contents. As a result, the 2 UART port would look like this. Now, we move on to the programming part. The first step is to open the UART ports. We can obtain the necessary call function from the Developer's Assistance menu. We will also add the assert macro that ensures the previous function call has been executed successfully without any errors. Then, we will initialize 4 variables to hold the transmission and reception data for each UART port. For the main program, we need to create a while loop. The first executions in the while loop will concern the transmission of data. So, we add the write function calls. These function calls require information on the content and size of the data to be transmitted, so we modify the calls accordingly. In the same way, we shall add the read function calls. In this case, we need to specify the address of the variable to store the received data. We will then add a software delay. In order to vary the transmitted data, we shall write a simple toggle procedure. If the value that has been transmitted is 1, then we shall set the next value to be transmitted as 0, and so on. To demonstrate the successful transfer of data and integrity of the value, we will add some LED activities based on the data. We will configure LED 2 and LED 3 to be toggled on and off based on the received data on each port. If UART channel 7 receives the data 1, it shall set the LED to high and light up. The same goes for UART channel 2. We have already initialized the transmitted data to be of opposing values. That is, when channel 7 transmits 1, channel 2 will transmit 0 and vice versa. Therefore, we expect to see a set of blinking LEDs which light up alternately. We can then close the while loop and build the program. Once the program has been built, we can upload the executable to our board. As we observe, the LEDs light up alternately, indicating simultaneous data transfer over the UART channels.